Yeah. Good afternoon, everybody. Good afternoon. Please try to unmute your speaker and let me know if you can hear me.
Good afternoon.
Good afternoon.
Unmute your speaker. Let me see if you can hear me.
Good afternoon.
Yes,
We can hear you.
Okay, good afternoon. We have few people in the class and we're still expecting some other people. So what we're trying to do is to give extra just 5 minutes. So this is just 5:05. So by 5:10, we'll start the class. I hope by then others should have joined. So this is 5:03. So by 5:10, we commence the class. Please, who is item 833? Please kindly help us change your name. Change your name. Let us know your real name. We can't be calling you item. Thank you very much. By 5:10, we'll start. Yeah, good afternoon, everybody. So at least we have enough number of people in the class now, so at least you can commence today's training. Please kindly confirm if you can hear me. Unmute and let me confirm if you can hear me clearly.
We can hear you loud and clear.
Okay, thank you very much. So today we're covering plumbing, water treatments, and sewage treatment. So because of the voluminous nature of the slide, I'll try to see how I can try to put justice. And on that plumbing aspect, I'll be looking at areas that are very, very critical that you can't do without. Then other ones you can just within your leisure time to like go through. Why we go to water treatment and sewage treatment. So for the first one, we'll be dealing with plumbing. Then by 6, we're going to have a short break. Once we come back, we're going to water treatment and sewage treatment. So can somebody just give us a brief definition of what plumbing is all about? Just a volunteer. What you actually understand by plumbing.
Okay, good afternoon, everyone.
Okay, do we have anybody who wants to actually give a try? Okay, Mr. Samuel, go ahead. Mr. Samuel, unmute your speaker and go ahead.
Okay, good evening.
Mr. Samuel, go ahead. Mr. Samuel Luashio.
Okay, so what I understand by plumbing is should I say running of pipe that supplies water either for usage or sewage evacuation.
Okay. Yeah. You actually tried. You tried, and like that is a point. Plumbing is just like, you know, in physics we talk about motion. There is a movement from one point to another, point A to point B. But plumbing is all about transfer of liquid, fluid, or gas from one point to the other through a medium. And that medium is, when you start talking about that medium, you start talking about your piping network, your sewage system, your drainage system, your sanitary waste, your sanitary fittings, your taps and all those stuff. Those are all. But in terms of plumbing, it involves a source where the liquid, the fluid, or the gas is coming from. Then the plumbing accessories, or let me say the plumbing wares, serve as a medium of transporting that fluid, liquid, or gas to the point of usage. Like in our different individual house, you have a source where water is coming from. Then there is a device that takes the water from the source down to a storage. From the storage, it comes into your building for your different uses. Then the waste goes into your drainage pipes. From the drainage pipes, it goes to your sewage system. And at times, if your sewage system is being treated, you discharge that into a public drain. And treating your sewage or treating your used water is termed as sewage treatment. And your water that is coming from the source, it's being treated, that is where water treatment plant comes into. But water is being used for different kind of purpose. You can use your water to wash your car, you can use your water to water your garden, you can use your water to wash your floor. There are several numbers of uses of water. So the one plumbing is from the Latin word. It is an art and techniques of installing pipes, fixture, and other apparatus in a building, and for bringing in supply of liquid, substances, or ingredients, and also removing them. It brings in and it removes. Let's have in the back of our mind that we shall be discussing 5 major areas. 1 is the source where the liquid, the gas, or the water is, or the fluid is coming from. Then 2, the movement of that liquid, fluid, or gas. The medium through which that liquid, fluid, or gas moves. Then the waste that are being generated. Then disposal of that waste. Please, can you help us to mute your mic? Thank you very much. So these are all the 5 areas we shall be discussing. From the source to the devices that move, then through a medium. What are those medium? Then from that medium to the used point. The used point, what are the waste generated? The waste generated is being moved by devices also to be discharged. So what are those things that are required? So in between the source and the point of usage, there is a devices that move it, and there is something that we call treatment plant. After the water has been used, there is something we call sewage treatment plant, which take care of our waste water. So now we need to talk about the source. What are those sources of? But because basically in facility management, we can't run facility without water. It's very, very key. Water is part of our top utility. Then that's why for this course, we shall be basically be dealing with water. But I can assure you, plumbing, either you are in oil and gas, you are in a process plant, like all these FCMG, you are a facility manager in all those areas. Plumbing, basic theory is the same everywhere. Either you are using your PVC, you are using your pressure pipe, you are using your white pressure pipe, you are using your galvanized pipe. It is the same plumbing networking that we're doing. Now, when you're talking about the source, where the water is coming from, you start talking about, you can either get your water from the brook, you can get from the sea, you can get from the well, you can also get from the rain. Then we start talking about borehole. These are all sources of water that we have. Those are gone are those days when we're still very young, that we have to go to the brook to go and fetch water. And when we come back, what our parent does is that they added alum. And once they add alum, the water settles at the base of the container, and they take the quality and the good water out. That is a form of water treatment. But at that period in time, we have a source, which is the group where we went to fetch the water. Then the devices that move the water is a human being as at that time. Please, kindly help us mute your speaker, sir. The devices that move the water is we, human being, because we have to use our head pan to move the water from the brook down home. Then at home, we do what we call treatment, which is either by adding alum or by boiling the water to make sure we do away with what germs and all these bacteria. Then we use the water then to take a bath and all the necessary things. Then we may not have taps, we may not have shower. We have something that is called baler. And the water from the bedrooms goes out as a waste. Then there is nothing like sewage treatment. Sewage is not being treated. We discharge the water to anywhere we like. But because of the fact that government is not paying close attention to aquatic living, that's the reason why it is recommended that you have to treat your sewage system. And I've made mention of some of the sources of water that we have. We have rain, we have the brook water, we have the sea water, we have well water, then we have bowl. But because it's not that all these waters are not good. But you remember then we've been taught that water must be odorless, colorless, and tasteless. That is just one parameter out of the three parameters that water should have. The parameter is the physical parameter. Physical parameter is talking about the odor, taste, and color. But the chemical parameter is talking about the dissolved solids. And what are these solids that are normally dissolved in our water? You're talking about lead, you're talking about calcium, you're talking about iron, you're talking about sulfur, you're talking about nitrogen. These are all solids that can dissolve in our water. And they have good impact on our body system. They still have an adverse effect on our body system if they are being consumed beyond the normal requirement for human consumption. And that's the reason why WHO and NAFDAC has a consumption limit for all this chemical decomposition in water. Then that is the second parameter. They were talking about the top parameter, which is the biological parameter. When you're talking about the biological parameter, you're talking about the fecal deposition in water. You talk about your E. coli, the Plasmodium. These are all biological issues that are related with water. And in order to make our water for safe and drinking, that is the reason why we have to do away with this. If I'm using my water for watering my garden, I might not be concerned about the biological aspect of the water, neither chemical aspect of the water. The only thing I needed to be concerned about is the water has to be clean. And if there is a water that I needed for surgical requirements, most of the time they go for distilled water, because distilled water are free of a lot of germs and bacteria. So the actual purpose of the water will determine the kind of treatment you are going to give to the water. So plumbing system include the supply pipe, the filter, and the drainage. Those are the three systems. All plumbing filter and traps, all sanitary and storm drainage system, vent pipe, roof drains, ladders, and down spout. These are all talking about plumbing system. So this is more like plumbing cycle. You know, when rain falls, within some hours, you seem not to see the erosion again. What has happened? The water has already percolated. And once it percolates, it goes to the earth crust. And once the sun comes out, the sun hits the ground up. The ground becomes heated up. And the heat started what? Evaporating. And you know, the higher you go, the cooler it becomes. The water, the heat that evaporates becomes condensate and fall as what? As rain again. That is more or less like a plumbing, like water cycle in terms of rainfall. But in plumbing cycle, you have the water from the what? From the source. You use the devices to pump it. It goes into a storage tank. From the storage tank, you distribute it to different parts of the building. You distribute part to the car park. You want to be using that one to be washing your car. You distribute part to your kitchen, some parts to your what? To your toilet and bathroom. And when you use this water, you use all it your drainage system to do the what? To do the connection. You collect it. And these are all your water waste. Then you either treat this water and send it to what? The public drain, or you keep evacuating your what? Your sewage system. So we have water supply and distribution system. What are those water supply and distribution system? There are two types of water you use in a building. You use hot water and you use cold water. Those are the two sources of, those are the two types of water you use in the building. And I've already discussed about the water cycle, that you have rainfall, the rain evaporates when sun comes up, condensate takes place, and after that we have precipitation, which form in form of what? Water. And I told us that we have several numbers of ways of getting water. One of the sources is groundwater. And we are talking about groundwater. You talk about well water, or you talk about borehole. And what is the advantage? Usually has an abundant water supply, require less treatment because of the natural filtering. But disadvantage are because of the organic matter and chemical elements. Usually treatment is what required. That's the reason why I told us that you always have what we call a chemical decomposition in the water. So, talk about physical properties of water. That is absorption, heat absorption, surface tension, capillary, and dissolving ability. And these are all challenges that water can have. And that's the reason why I will be going into water treatment and alongside with this plumbing, so that we have little or nothing to cover underwater treatment. At times, when you do your borehole, but when we do well water, we don't even do that most of the time. But when you do your borehole, the best way to approach it is that for you to first of all factor out what exactly do you need the water for. And what you need the water for will inform the kind of treatment you are going to give to the water. Assuming you need water for drinking. So there are several numbers of problems that can be associated with water before it can be said that it is safe for what? Drinking. You can have your water to be acidity, and when your water is acidity, that means it is below the normal required pH. The required pH for water consumption is between 6.5 and 8.5. pH value for water consumption is 6.5 to 8.5 according to NAFDAC and World Health Organization, that is WHO. So once your water is acidic, is the kind of treatment you are going to give to it is differ. Then when your water is, when you have hardness of water, it has another treatment as well. When you have turbidity, it has another treatment. These are all challenges that you can come across in terms of water. It is as color, there are some other treatment you can give to it. If it is being polluted, that is as odor, it has other treatment that you can give to it. And several types of treatment that you can do is sedimentation, which I've already mentioned that. Those days when we're still very young, we use alum to what? To treat our water, or we boil the water before it becomes safe drinking. So sedimentation is like when you add alum to your water and all the contaminants settle at the base of the containers that contain the water. That is all what sedimentation is all about. Then we have filtration. I can use a layman theory to explain filtration. Filtration is like when the rain falls, the water percolates. And when the water percolates, it goes to the earth crust. That is more or less about filtration. And that's why if you look at all our facility, we always have a stainless steel cylinder, which is 2 in number, and it has media inside. The function of those media are to what? Filter out all the contaminants that are coming, the chemical contaminants that are coming alongside with the water. It filters them out so that at least you have a clean crystal water coming into your storage tank. So disinfection, you can use chlorine to do your disinfection. It's a disinfecting agent, and it is also a bleaching agent as well. These are part of what we still come across in water treatment as time goes on. Another source of water is well water. So another one is well water. Then we'll talk about drilled well. Drilled well are our boreholes. So Now we discussed about the source at which the water is coming out. Now we need to talk about what are the devices that takes the water from the source down to the use point. Then I said we go to the brook to fetch water. Once we fetch the water, we as a human being, we use head pump to fetch the water. We are the devices that move the water from the source to our house where it's going to be used. But nowadays, we use our pumping machine to move the water from the well or from the borehole to the storage tank. Or we allow it to pass through treatment before it gets to the storage tank. And what are those devices that we use? We can either use a surface pump or we use a submersible pump if it's a borehole. But if it is a well, we can use a surface pump, we can use a submersible. The only difference is that if we're using a surface pump for a well, we won't immerse the pump in water. Just like your element, your eating element. We have wet elements and we have dry elements. The example of your wet element is your boiling ring, while the example of your dry element is your electric iron. So the pump is the devices that move the liquid, the gas, or the fluid from the source through a medium to what they use, the point at which it will be used. And your pump can be reciprocating pump. We have positive displacement pump and we have negative displacement pump. Under positive displacement pump, we have reciprocating pump and centrifugal pump. These are devices that you can use to move fluid such as liquid or slurry. A pump displaces the volume by physical or mechanical action. That is the function of a pump. And this is a surface pump and it's also a centrifugal pump. These are all impeller pump or multi-stage pump, which are being used in oil rig or at times as our own normal submersible. Then we have a submersible pump, and this is an example of a sewage pump. This has a floating switch attached to it. Once the level of the water gets filled up, the pump automatically starts by itself and it starts pumping the water out. And once the level is low, it automatically switch off the water. So this is another example of your jet pump or centrifugal pump. So your water storage, you can do two options. The first option is that you either feed your building with gravity. So you supply water into the storage tank and the water flows into the building through with what? Gravity. And when you have this kind of system, there is always what we call pressure differential. And that's why if you observe it, that if you're living in a story building, you discover that the ground floor always adds water faster compared to the first floor because of what? Pressure differential. But when you have all your tanks located on the ground floor and you use electromechanical pump to distribute the water, you have an equal pressure distribution in the whole building. So your pneumatic water tanks is an example of electromechanical. Then that brings us to all the accessories that we use we've discussed about the source at which the water is coming from. Now we talk about the devices that move the water. Then we need to talk about what are the sanitaries that are being used. The first one is a valve. Can anybody just give me a brief definition of what a valve is? I need a volunteer. What is a valve? Please kindly signify by raising up your hand. Yeah, Mr. Kingsley. Go ahead. Unmute yourself, please.
Good evening. A valve, I will liken a valve to be like a switch where you can give access to flow of water and also restrict the flow of water. Thank you.
You said a switch where you can switch on or switch off, right? Mr. Kingsley.
Yes, a switch where you can switch on.
Your switch has a two-way system. It can either be on or off.
Yes, where you can switch on and at the same time turn it off. So is to give allow flow and to
Okay.
restrict flow. That's the essence of the valve.
Okay, Mr. Michael.
Me, I will
Good
call
evening.
it a control. A
You said
control.
what?
I said I will call it a control of water system. It controls
A
the
control
flow.
of water system.
Yes.
Okay. The two of you are both right. A valve is a device that is used to control the flow of liquid, fluid, or gas. That is what a valve does. So we have several numbers of valves that we can use. We have full wave valve. We have wedge shape. We have double disc valve. We have air valve. We have gate valve. We have global valve. Those are the example of the one that we always have at home that has a cross like this that you keep turning until when it's finally closed. And that is different from air valve. Air valve, you close it at once it closes and you open it at when it opens. Then an example of a globe valve are plug type, conventional disc, and composition disc. These are all valves. Then a check valve. Then you talk about a check valve. A check valve is just more or less like your non-return valve that doesn't allow the liquid to flow back. It is just only one way. It is called check valve or flow valve, non-return valve. Then you have what you call angle valve. You know, your water heater, the water that is coming from the wall that enter your water heater, or the water that is coming from the wall that enter your washing hand basin has a control. And it has what we call a flexible connector attached to it. That is example of an angle valve. It has one inlet and one outlet. So you have foot valve. Foot valve are if you have a well in your building and you have a surface pump that you are using to pump the water from the well into your overhead tank. The plumbers always install the devices, and that device is called a foot valve. It is always at the base of the riser pipe that goes into the well. The function of the foot valve is one, to prevent dirt from going into the pump so that it will not damage, in order not to damage your impeller. Then two, to ensure that there is a retainment of water within the riser pipe. It serves as a non-return valve at the same time. Then you have a safety valve. A safety valve is like a valve that is being installed on your pressure cooker, that in case the pressure cooker doesn't discharge the pressure inside, if the automatic solenoid valve failed, then you can use the safety relief valve to discharge all the pressure in that cooking system. You have your faucets. Your faucets are more like your taps. You have a mixer tap, which is like having the combination of hot water and cold water together. The examples are all your compression cork, your key cork, your ball faucet, and your hose bibs. Your hose bibs are those ones that you can see within a car park that you can easily attach hose to it and use it to either do washing of your car or wetting of your flowers. So then that brings us to the distribution network within the building. You have service pipe, you have water meter, you have distribution pipe or distribution supply. Service pipe, your main distribution system. Other network take supply from that main distribution system. Other one that take supply from the main distribution system are referred to as service pipe. You have riser pipe. The riser pipe is the pipe that takes water from your well to what? To your tank, or the pipe that's being attached to your submersible and takes the water out into where you want to use. Those are example of what? Riser pipe. Then you have feature branch, you have feature supplies. You have a main feature. Your main feature is the main supply pipe. So let's talk about sanitary drainage system. After you have taken the water into the building, you use the water. When you use the water, it becomes a wastewater. How do you get the water out? That's the reason why your hand wash has what we call a bottle trap. Your zinc has a trap. Your toilet has what we call pan connector. All these are more or less like fittings or plumbing fitting that take your wastewater out and direct it down to your what? Drainage pipe. From your drainage pipe, it goes into your what? Sewage system. So when you are running your drainage pipe, one of the plumbing rules you have to ensure is that the the drainage pipe should take the shortest possible route to the house sewage system or the terminating point of the sanitary system. So there must be as short as possible. And that's the reason why when you look at your drainage system, there is always what we call a manhole at an interval along the line. So it is not being run continuously. And the reason why it is being done that way is so that you have the opportunity of, in case there is a blockage in the nearest fixture, you can easily use your K-rod to get everything cleaned, and you open your manhole to remove any blockages that's within your system and get it clear up. Then you have control components such as clean out. Clean out, example of your clean out are your bottle traps. Your vent should be located strategically so as to ensure efficient circulation, and also to make sure there is no what we call airlock within your system. Then wastewater collection, that is subsystem of the sanitary system. These are your wastewater collection, which are your floor drains, your ventilation system. And that's why you see that your sewage system, there is always what we call a vent. It could be either located on top of the inspection chamber, or you install what we call a chimney. A chimney is just this rotating devices that's being fabricated with stainless steel that work alongside with the wind. So as long as the wind is blowing, it's also what? Rotating at the same time. Once it rotates, it takes the odor away from your what? From your sewage system and discharge it out. And that's why if you look at some toilets, you see what we call a wall-mounted extractor that extract the odor from the what? The toilet or the bedroom and discharge it out. We have waste pipe, which is the one that convey your water, your wastewater into your sewage system. Your vent pipe, example of your vent pipe is the chimney that I mentioned earlier on. You are trap. The example of the trap is seen under your sink or your under your sink or your hand wash zinc. The function of the trap is that in case it gets choked up, you can easily remove it, wash it clean, and replace it. Then you have stack. Stack are being installed at the back of your building. If you go home and check very well, you have your sewage system at the back of your building. There is always a stack that comes from the sewage system out. It has a kind of a net at the top of it. And what that does is that to extract all the heat from your sewage system and discharge it out. You have branch. There is what we call a main piping network. All other branches take supply from the main branch. If you have a 10-story building, you have one single main branch that take water from the source down to the 10th floor. But other floor within the building will take their supply from the main riser branch. So in plumbing system, it is required that when you are doing your sewage system, you must ensure that your sewage system is like 6 meters away from your fence wall. Why? Because like on the mainland, the wall of your sewage system are not being cemented. It is being left with perforated block so that the floor, the ground around that sewage system can be what? The water around that place can be what? Percolating. The ground sucks the water away. Then you have only the liquid form of your waste that is being retained in the sewage system. But because it will come to a point that the ground will become saturated, and once the ground is being saturated, it can cause the wall of your sewage system to fall off. And once it falls off, if your fence wall is being located to that sewage system, it will cause what we call structural differential within your fence, and that fence will collide. But on the island, you still don't need to, because that your sewage could be leaking. Because your sewage, most of the sewage on the island are casted sewage. It is casted has sunk into the floor. And at times, you can't rule out leakage from your sewage system. Because of the fact that you can't rule out sewage, you don't locate your borehole close to your sewage system. You try as much as possible to move 6 meters and above away from the sewage system when you are locating your borehole or the fence wall. Then, when you are doing when you are taking your branches of supply to other floor within your main branch, in line with the plumbing requirement, you may ensure you use a 45 wide branch. 45 wide branch means that an angle on a straight line is 180 degrees. Then, if you take 45 away from 180 degrees, you have 135. So that means in case there is a blockage in the near future, your K-rod, the one that you are using to clean your drainage system, can bend at an angle of 135 compared to an angle of 90 or 45. It's not possible. That's the reason why when you are moving from horizontal to horizontal, you maintain a 45-degree wide branch. Then when you are moving from vertical to horizontal, you maintain the same 45-degree wide. So when you are doing horizontal to vertical, the same 45-degree wide or 60-degree branches. That is what the law of plumbing says. And it is being said that when you are running your drainage system, you must maintain a slope of at least 2% or 20 mm per meter. That is 1/4 foot per meter. For every 1 meter, you must go by 2 degrees down. For another distance, you must go by another 2 degrees or down, 2% down. The reason why you have to do is that even with a drop of water or inside your drainage system, it will flow straight down to your drainage, your sewage system, so that you don't have water being retained in your wastewater pipeline, so that this can cause what we call a backflow of odor. These are all examples of traps that I told us. I said your kitchen zinc where you wash all your dishes, or your hand wash zinc, they all has what we call bottle trap. But nowadays, bottle trap is not that much common. What we have now is magic waste. And that is what your plumber most of the time refer to as what? Magic waste. That is what connects your hand wash, your basins and all this stuff to your drainage system. So clean out are more or less like your chamber, inspection chamber. So you must install your clean out at every 15 meters, that is 50 feet of the total developed length or fraction. So if you have a length of, let me say a plot of land, or a plot of land to be sincere, or let me say a land that is 100 meter length. That means at every interval of 15 meters, you must install what we call a manhole, so that in the nearest future, if there is an issue, you can easily open the manhole and get it clean. So, at the upper terminal of every horizontal sewage or waste line, you must install what we call a clean out or a manhole. At each run of piping more than 15 meters, so any piping network that is more than 15 meters, you must install what we call a clean out at an interval there. Additional clean out shall be provided on a horizontal line with an aggregate offset angle of what? Exceeding 135. So once your angle is being greater than 135, it's already getting closer to maybe 150 or 180. That is becoming an angle on a straight line. That means you have to install what? A clean out at that period in time. So ventilation, vents, a pipe or opening used for ensuring the circulation of air in a plumbing system and for relieving the negative pressure exerted on traffic. That's why that you see that in most places, you always have this vent pipe at the back of your what? Either your toilet or at the back of your bedroom. It is meant to take all your what? All your odor away from your toilet and bedroom. And at times, this vent can be used as a wet vent. It becomes a wet vent in such a situation whereby you have your floor, your roof is being decked, and you have what we call vaulting on top of that roof. Then you have roof gutters. You can connect your roof gutter to your vent, because that vent is only taking care of what? Odor out. So when you install it to take rainwater away from your roof, it is referred to as what? Wet vent. So you have local vent, a pipe or shaft to convey foul air from a plumbing fixture or a room to the outside air. Then we have dry vent, a vent that does not carry liquid waterborne waste, but stack vent is an extension of soil or water waste stack above the highest horizon drain connected to the stack. Then your vent stack, the vertical vent pipe installed primarily for providing circulation of air to and fro any part of the soil waste of the drainage system. So your vent stack provided exchange of what? Air. It takes air into your what? Into your sewage system and take air out of your sewage system to ensure there is what? Balance of air. So bacteria in septic tanks to encourage decomposition. An aerobic bacteria relies on oxygen to survive, while anaerobic can survive in places without oxygen. Because of this aerobic effect, because there is no oxygen, that is the reason why you dig your borehole and you discover that water is smelling. This can be only be caused by this aerobic issue, or it can be caused by sulfuric dissolved in water. These are all examples of how you can construct your sewage system. Dimension length is 1.5 meter, width is 0.9, and depth is what? 1.2 meter. These are all the way you can design your sewage system. Then
Is that dimension, that dimension, is there a standard, sir?
no. It's not a standard.
Okay.
It all depends on the available space. You have several numbers of design that you can use. That is not the only designs. There are several numbers of design, which is at times is being informed based on the dimension, based on the available space.
Thank you.
So there are some times that you have your facility being logged with pool of water, and when the flooring is to be done, the flooring is done in such a way that it diverts all the flow within that facility into what? Into a sewage system. And once it diverts everything into a sewage system, it always has what we call a strainer. The function of the strainer is to allow unwanted or foreign material to go into the sewage system. And that's why after rain, you either require your plumber to climb the roof, this strainer that is on the roof, remove it and clean it and get it clean before another rain will fall. Or if it is on the floor that is being installed, you remove it, you clean it, so that at least in case you are discharging another waste, it is easier for that waste to flow. And for that kind of a situation whereby you have a dedicated sewage system for your wastewater, you definitely need what we call a sewage pump inside that sewage to remove that wastewater. I'm so sure almost every one of us are familiar with roof gutter. You use your roof gutter to collect all the rainwater from the roof and send them to what? To either you send them out or you send them to your what? Sewage system, and use your sewage pump to pump them out. And that brings us to the end of plumbing. Then we'll have a 5-minute break. After that 5-minute break, we'll come back and we'll start water treatment system, facility water system, and sewage treatment plant. Thank you very much. 5-minute break. We come back by, this is, check the time. This is 5:55. They'll come back by 6 to commence water treatment and plumbing. Thank you. So, water purification. What is water purification? Okay, Mr. Austin, please go ahead.
All right, I want to ask, sir.
Okay, sir.
The sewage that will leave open in the mainland.
This way that will do what?
The sockaway pit
Yes.
that will leave open in the mainland and in the island that we seal. Which one is
Yes,
a
sir.
global practice?
Yes, sir.
Yes. So which one is a global practice?
The two of them are tenable is because the reason why you're using one on one side and you're using the other one on one side is environmental condition. Because island is already the water, the soil on the island is already waterlogged, is already saturated. So there's no any water that can percolate. That's the reason why you did what we call casting and you erect the sewage tank. But on the mainland, your water can still percolate, and that's the reason why you have a soak away system on the mainland. But that is not possible on the island because there's nothing that can soak the water away.
All right, sir. All right.
Okay. So, I said earlier on when we were dealing with plumbing, I said the purpose to which you want to use the water will determine the kind of treatment you are going to give to the water. If you're going to use the water for sanitary purposes alone, it has a separate treatment you can give it to. But if you're using the water for chemical necessity, that means you're going to use another form of what? Treatment. If his water is meant for drinking, that the water is safe for drinking doesn't mean it is a quality water for medical purposes. So there are two different things. So you can't use your pure water or your bottled water to wash your critical blade. So they are of two different purposes. Most of the water that they use in the clinical environment are called distilled water, which doesn't go through any filtration or whatever. It is water from what? Distillation. So purification is removal of contaminant from what? Untreated water. The water that's not gone through treatment is called untreated water, or you call it raw water. Sometimes removal during the process of purifying what are you trying to take away? Algae. You're trying to take virus away. You're trying to take bacteria away. You're trying to take what? Manganese away. These are all solid that can dissolve in your water. Suspended solid like iron, sulfur, and other chemical pollutants. The goal of water purification is to produce water that is fit for what? A specific purpose. The word doesn't say that is fit for drinking. That is fit for what? A specific purpose. So if you now want to use your water for drinking, there is another set of treatment you are going to give to it. So you have water purification method. You can use chemical, you can use biological, you can use physical processes. And under biochemical, you have chlorination. Under chemical, you have chlorination. And under biology, you have activated carbon and slow or filter. You have under physical, you start talking about sedimentation, filtration, and what? Distillation. These are all way of purifying your water. So what are the 3 steps you can use during water purification? You can talk about sedimentation, which is addition of either alum or this other chemical that can cause coagulation. Then kinetic degradation by using chlorine, that is taken out of chlorine is taken out of water and converted into chloride. You use chlorine to remove what? Your color. Then you talk about activated carbon, which attract positively charged contaminant and they stick to the water. These are all 3 steps you can use in purifying your water. Distillation, I've told us, distillation about is like you subject the water to temperature. The steam evaporates and you accumulate the steam. You allow the steam to cool or form condensate and you take it. That is what you call distillation. But because of the fact that it consumes a lot of energy, so this kind of process is possible in an environment where you have all this chemical. If you're working in the chemical industry, you can use your waste chemicals instead of disposing of that waste. to generate it in order to heat your water and get a distilled water out of it. Then filtration, I've explained filtration to us that is when the rainfall, it percolates and it goes to the earth, and the earth serves as a filter and filter the all the foreign material that comes alongside with the water, and you have a crystal clean water inside your earth crust, and that is where your borehole has the advantage of what? A very clean water. Filtration is removal of remaining particles in water through a filter. The filter is made up of layers of gravel, sand, and crushed anthracite. The suspended impurities in water are collected by filtration. Water is passed through a filter at a controlled flow rate. The filter are regularly cleaned by backwashing. Backwashing is like you are trying to clean all the contaminant that's already accumulated on top of the cylinder, and you are trying to wash them out and discharge them away. Then coagulation, before sedimentation will take place, coagulation has to take place first before coagulation. Adding of alum or polymer to raw water, then tiny fine particle of dirt, the water stick together, and the more they stick together, the more their weight increases. The more their weight increases, the more higher they become. They become higher than water, and they can now settle at the base of the container that contain them. Flocculation is more or less like the same thing as that of water, but if you have an aeration tank, flocculation is better explained. Coagulated raw water is gently mixed by large chemical particles, cause the fine light particle to mature into larger, denser, and heavier particle called flux. Flux is produced by removal of ion through aeration or chlorination. So that's why I said flocculation is better achieved when you have an aeration tank. Sedimentation, which I've already earlier explained, that when you add alum to your water, all the watered sediments settles at the base of the container. Disinfection is like when you're using your chlorine to take care of fungi or viruses in your water, or you are taking care of what? Bacteria in your water, you add chlorine. Then the second advantage of chlorine is that it serves as a what? As a bleaching agent. And that's why most of the time, if you have a colored water, you can add chlorine as part of the treating chemical treatment agent. Then you have fluoridation. Fluorine and chlorine are almost the same thing. So they are almost doing the same job as far as water treatment is concerned. The only advantage is that fluoride helps you in terms of your dental cavity. That is just the difference between the two. Then reverse osmosis is just a reverse of the normal osmosis that we talk about in our biological in those days. You know, the normal osmosis is movement of water from what? A low membrane to a higher concentrate through a semi-permeable membrane. But in terms of reverse osmosis, it moves from higher to what? To lower through a semi-permeable membrane. The process of passing water through a water system that has one or more filters and ultraviolet light, you use your UV to take care of your what? To take care of your microorganism, because the light is as high as that of a X-ray light or your photocopier machine light. And it is always recommended that you remove and replace your UV light at the end of 9 months. It has an expiring time. 9 months is the best time. And the content inside your media, it is required that you change them between 12 to 18 months and replace them with another set of media. So water treatment plants installation, how do you install? The first thing that I said earlier on is that when you want to install your water treatment, determine the purpose you want to use the water for. After that, take the sample of the raw water from the borehole to the lab, analyze the water, and the result of the analysis will tell you, it will give you the detail, it will help you to determine the kind of treatment you are going to give to the water. Determine water quality, and knowing the water quality is a major key in installing a water treatment plant. It determines the application for treatment. Water with higher quality will require minimal treatment. Then when you are selecting your treatment system, consider the factor below. 1, are there any hard water issue? Is the water hard? What is the water quality needed? Is the water required for watering of your garden? Is it required for your sanitary purposes? Is it required for what? Drinking. Then water treatment system capability. What is the capacity you want to put in place? How many liters of water do you want to be generating on a daily basis? The provision of good quality water. The treated water reduces harsh effects on skin. The treated water does not damage what? Laundry. These are all what you need to consider before you start thinking about the number, the type of treatment you are going to put in place in water treatment. So when you want to analyze your water, you do 3 stages of analysis or 3 parameters to test for in water. 1, you do physical testing, you do chemical testing, and you do biological testing. Physical is to tell you about the color, turbidity, the odor, and the taste. And chemical, what are those, the subsolid in that water? What is the pH of the water? Then biological are indication of microorganisms, mainly bacteria in that water. And when you analyze your water, the result is always in this format. You know, I said your pH should be between 6.5 to 8.5. Your chlorine should be between 1 to 0.2 ppm part per million, while your TDS should be 500 milligram per liter, total dissolved solid. All your chemical dissolved solid in your water should not be more than 500 milligram per liter. So this is for copper, this is for your iron, this is for your magnesium, this is for your chlorine. These are all what it is expected for you to have. Say your water is a quality water. Then pH, there is potential for hydrogen adjustment. Filtered water pH is adjusted by adding lime. You can add lime to the water in order to increase the pH. Lime achieves the desired pH target. Lime helps to stabilize and neutralize naturally your water. Lime reduces corrosion in distribution water. Adjusting the pH makes the water more basic and less corrosive to pipe. It extends the life of the disinfectants residual. These are all the advantage of when you add your lime to improve the pH of your water. So when you have your pH lower than 6.5, that means the water is a bit acidic. So operation and maintenance of water, we have daily, we have biannual, you have monthly, you have quarterly, and you have annually. And daily means you do your dosing, you do backwashing, you check for the functionality of your filtration pump, your dosing pump and stereo, your transfer pumps. You check for your pH of the chlorine, then your TDS level. Then monthly, you wash your dosing tank, service all the chemical dosing equipment. Then quarterly maintenance, you washing of the aeration tanks and water storage tanks. Then you replacement of the filter media. Biannual, that is twice in a year, carry out overhaul of the pump. Then annually, service the bowl. So servicing could include injecting your chemical to flush the bowl, or at times you could do what we call compression. So you compress the bowl with chemical as well. To make sure that your screen inside the bowl are being through in case there is what? There is clay settlement on the screen of that bowl. Because once there are clay settlements on the screen, it will reduce the volume of water getting into the column. And your submersible will have more work to do in order to get water. Then the rate of water you are getting will be reduced. What are the hazards associated with the water treatment plant? Exposure to hazard substance, which is like your chlorine, because your chlorine is choking when you open it. So that means you have to have a nose guard when you want to pick your chlorine to inject your chlorine to your dosing tank. There must be water on the floor to avoid trips and fall. Exposure to high level of noise. Exposure to toxic substances, electric shock, fire hazard, suffocation. Because if you are asthmatic patient, it's always advisable not to near chlorine. Then presenting measures. Safety shoe with non-skid sole should be worn all the time. Use appropriate ear protection. Properly guard all equipment moving parts. Use your MDDS, that's manufacturer specimen data sheet. Check air quality of the confined space. Thoroughly check all electrical equipment. Use respirator and gas mask. Wear coverall. Wear hand gloves. These are all preventive measures necessary in your water treatment plant. What are the components of a water treatment plant? You have aeration tank, we've already mentioned. You use your aeration tank to take care of your odor in your water. And in aeration, you have water to air and air to water. Used for removal of hydrogen sulfide, rotten elk smell, and iron from what? Water. Air is introduced to the aeration system to treat hydrogen fluoride and iron. It has a vent system that releases hydrogen sulfide gas to the atmosphere, provide a turnover of air in the tanks. Then that is aeration. Then the second one is filter vessels. These are all the diagram of filter vessels. It is used in the final stage of water treatment process. Remove the remaining suspended particles and unsettled flux in the water. Use of backwashing, filter vessel media, activated carbon, rapid and sound filter, pressure filters. Dosing pumps. Use your dosing pump to take the dosing chemical from your dosing tank and inject it into the aeration tanks. But because your chlorine and alum are two different things, your alum is completely soluble in water, but your chlorine is not completely soluble. It is incompletely soluble. That's the reason why you always have a stirrer installed in your chlorine tank so that the stirrer continuously keeps stirring the chlorine and disallow it from settling down so that you have a quality concentration of chlorine chemical being dosed into your water tank. These are all stirrers. Each of them has a specific purpose. You can see this one is spiral, this one is tiny spiral, this one has blade, and the blade is like 4. This one has 4 blades, and this one has just only 2 blades. Each of them has a specific place where they can use them. You have transfer pump. I've already discussed one or two things about pumping machine with us when we're discussing about what? About plumbing. Pump are used to transfer treated water to storage tanks. Its primary function is to move water from one location to another. Water is treated when the pumps create a pressure difference. The pressure difference is what draw the water in and transfer it as the pressure changes again. These are all what we need to know about water treatment plant. Please keep jotting all your questions down so that we can take care of all the questions after the class. Then we'll be going to sewage treatment plant. So can somebody help us with a very little knowledge of what they understand by what sewage system? Sewage treatment plant, please. Kindly signify by raising up your hand. Okay, Mr. Chuchu, let me call on Mr. Chuchu first before Mr. Bamidele. Mr. Chuchu, I'll call you first, then Mr. Bamidele, you'll be next.
Yes.
Go ahead, Mr. Chuchu.
Yes, thank you.
Yeah.
Sewage treatment, I understand. What I understand by sewage treatment is the treatment of wastewater from domestic use or industrial use, some cases, and how we release it into the environment or repurpose it for use.
Thank you very much. You're perfectly right. You're perfectly right. Mr. Bandili.
Thank you. A sewage treatment plant is used to treat, but not only sewage, bad water, but waste from the sanitary, and is to avoid, instead of processing it out and maybe bringing in truck that will come and pack the waste in the sockaway. The sewage treatment plant helps in processing and making sure that the sewage does not smell, and it helps in disposing the waste in a proper way, so that the environment will look neat and clean. Thank you.
Very good. Mr. Absamad.
Yeah, good evening. To me, sewage treatment plants is actually a type of technique whereby harmful or toxic substances that come from waste products, like liquid waste products in our workspace are being recycled or are being treated to avoid environmental pollution? Thank you.
Thank you, Mr. Absalat. Recycling is another option again. You are actually right. Yeah. Mr. Timitokwe.
Good evening.
Good evening,
I would
sir.
say, yes, sir. I would say the sewage treatment plant is a system that is in place to manage liquid waste in order for us not to cause pollution, and also a means of recycling it for reusage. Thank you.
Thank you very much. We've all spoken well. We've all said it all. You can treat it and dispose it of, or you recycle it again. Yes, because the recycling processes is what is basically being practiced in America today. So they recycle their waste to reproduce water again. Mr. Samad, you are still raising up your hand. Do you still have something to say, or it's still part of the initial? Okay, thank you very much. At least it's good that we all have an idea of what a sewage is all about and why do we need sewage treatment. So what is a sewage? Household liquid waste from our bath, our toilet, our kitchen, or liquid waste from what? Industry, which we both said, and I agreed perfectly with it. And this waste can be disposed of after being treated, or we can recycle it again and reuse it. And what are the processes? You have the water that contain oil, grease, grit, and traps from your waste. You now send it to what? The sewage treatment plant. Once you get to the sewage treatment plant, the first thing that's been done is that there is a place where we call the receiver point. The receiver point has a bar screen. The function of the bar screen is to filter out all the foreign material that is coming alongside with the waste, like your nylon, your bottled water, your pure water nylon, your sanitary pad, your sticks, stones, sand, and everything. The bar screen filter those one out, and from there it goes to where we call equalization tank. From the equalization tank, it goes directly to the aeration tank. What happens at the aeration tank is to take care of every odor that is coming with what? With the waste. Then from there, you allow it to settle, because by the time you add 1 or 2 chemicals and everything settle, then you take the clean one out and the settled one form what we call what? A sludge. And from the aeration, from the settled one, the water pump, the sewage pump, take care of it, it pumps it out and passes it to the what? Clarified water sump. And from the water sump, it goes through what? Sand filter. The sand filter filtered it, then it goes through the activated carbon filter, and the activated carbon filter further removed the odor. From there, it goes to treated water tank. Then you can now pick it further from the treated water tank to go to, you now provide what you call water softening. And how do you do softening? You add what we call lime or soda ash to it to soften the water. And after doing that, you can still add chlorine. And why are you adding chlorine? The reason is for you to disinfect what? The water. And this kind of water can be used to flush your toilet, to wet your garden, to clean your car, and clean your environment. But in case you want to turn this water to what? A potable water. Now that means the treated water has to go through what we call micron filter. And micron filter means we have 5 micron, we have 1 micron, we have 0.5 micron. The human hair, the thickness of human hair is 80 micron. White bacteria are 30 micron sizes. So you can see that when you use a 5 micron filter, there's no any bacteria that can go through it. And we have what we call ultra filter. From there, it goes to a RO filter. RO filter is reverse osmosis filter, which is your membrane. Then that makes the water to become a potable water. These are part of the processes. These are an example of processes they use in America today. Then you have the equalizing tank. The water is being extracted and sent to what we call the watering system. And from the watering system, the water is this water to sludge, or you take it to what we call cake bag and dispose it off. And what are the type of sewage system we can have? One, we can have activated sludge process system. What is the activated sludge process system? You remember that somebody mentioned it initially, that we can recycle the waste. ASP is a plant recycling waste product. That means your waste generated is being recycled to produce water and used for another purpose again. The plant recycle waste products with bacteria that are live, bacteria that are settled to the digestion chamber. This speed up and activate the raw sewage digestion. Then you can use rotating biology contactor system, RBC. This requires either quarterly, biannually, or annual maintenance. The maintenance ensures optimal performance of both the mechanical part or internal moving part. Then there is another one again, which is called extended aeration sewage treatment plant. This digests solid and liquid waste in the central compartment. You have the incoming, you have the outgoing. So it goes from one place to the other until it gets to the final stage. It comes in at this point where you see my mouse moving in. Can you see the movement of my mouse, please? So there is a mixer that mixes the waste water. And from there, it goes to the first stage where oxidation takes place. Then from there, the waste sludge settles down, while the mixed liquid comes out, and you have the sediment tanks. Go to the sediment tanks, and the effluent water goes out from there. Sewage is aerated for a longer period. Plant is maintained biannually. Sludge is removed between the period of 1 to 2 years. Does not work well when overloaded. Work better when reasonably loaded. Consumed more electricity because of the fact that it generates a lot of sewage and sludge, and you need to keep the system running consistently. So filter sewage treatment plants need only an annual maintenance, does not require electricity for process. Then you have ridge bed sewage treatment plant. Plant is either in vertical or horizontal bed. Vertical bed treats sewage better than horizontal bed. And horizontal bed sometimes discharge bad effluent quality. Vertical bed runs on electric pump, which are expensive. These are all examples of sewage treatment that you can use. Then you have the SFF, submerged aerated filter sewage treatment plant. Fixed film biological reactor submerged in a box for wastewater purposes. Then we have suspended media filter. You know, the most common one that we use here in Nigeria is the one that we call the fat trap, which is made out of stainless steel. Suspended media filter, SMF, sewage treatment plant, is a process of using sandbed of different sizes and fabrics, etc., to filter the effluent from the sewage primary settlement tank. Then you have sequencing batch reactor. It's also an example of what a sewage treatment plant you can use. Then what are the kind of maintenance activity you can give to your sewage treatment plant? You can do quarterly, you can do biannually, you can do annually maintenance. Maintenance ensure plant the function efficiently. Maintenance prevent the plant from becoming pollution hazard. Then what are the processes that you can use in treating your sewage water, your wastewater? We have pretreatment. Pretreatment include, which is the first stage of treatment, removal of all foreign materials, which is being done by the bar screen. Removal of material from raw waste sewage. Material removed are trash, sticks, rags, cans, leaves, and branches. Pretreatment is carried out with mechanical automated bar screen for large population. Manual screen for smaller operation. Manual screen is more or less like you use, once they want to discharge, you have like 2 or 3 people holding the screen. While they discharge, the screen removes all the unwanted foreign material that is coming with the wastewater. During the pretreatment stage, you have removal of grit. Grit is all foreign material that comes along with your wastewater. You have allowing sandstone grit settlement, removal of large objects. What are those large objects? You have your napkin, your sanitary towel, your face wipes, your cotton board, and all those things. Then what are the other things you remove? Once you do that, you know, these items are heavier than water. They settle at the base of the receiver. Then at the top, you have your oil. because it's less than water. It stays at the top of the water. Then what do you use? You use skimmer or you use blower. Skimmer is just like example of this larger spoon that these people that are frying biscuit, akara, they use to scoop all the small beans seed in the oil. So you use your skimmer to scoop all the oil that is floating on the waste away. Then from there it goes to you equalize the flow, providing variable discharge control, bypassing the cleaning. Use of aerator. So from there it goes to your aeration tank to remove what you call odor. After the pre-treatment, the next stage is your primary treatment. During the primary treatment stage, you had the clean the sewage after removal of the sediment, and you have already performed what you call skimming. You have your sewage, or you have your wastewater without fat and without any debris. You had it in the aeration tank. And the reason why is that you allow other foreign particles, which are tiny ones, to also settle at the base of the basin. Floating of solid oil and grease to the basin surface, removal of floating and settled material. Discharge of remaining liquid into the secondary treatment. So after all the necessary foreign material has already settled at the base of the container, you can now transfer this liquid, this waste liquid, into the secondary treatment. And in the secondary treatment, what you do is you remove the suspended and biological matter from the wastewater. You separate the microorganism from the treated water. You break down the small and indivisible nasty bugs, which are more or less like ants or whatever that comes along with your water, and also the bacteria. Then after the secondary treatment, there are two stages you can have during the secondary treatment. You can have fixed film or suspended growth system. Either of them is classified as secondary treatment. After the secondary treatment, you go to what we call tertiary treatment, which is more or less like the final stage of your treatment. Then the second treatment, you have fixed film or attached growth system. Passage of sewage over a media. You pass it over a media and allow all the foreign sediment to settle at the top surface of the media. Removal of high level of organic material. Then suspended growth system. Mixture of biomass with sewage. Operation of biomass in a smaller space. Then after you have done this, this cleans wastewater you generated from that secondary process now goes to what we call tertiary treatment. In the tertiary, what you actually done is that rejection of very fragile and sensitive ecosystem. Disinfection, you carry out what you call disinfection, that is by adding either fluorine or oxygen to the water, or chlorine into the water. Remember I said chlorine serves two purposes, either as a bleaching agent or as a chlorination. So with that, we can have a more clear waste water. And these are the kind of water you are in line with legal, you can discharge them into a public drain, or these are wastewater that are considered not having impact on aquatic living. And that's the reason why if environmental agency comes to your facility, they request for your wastewater analysis report. And your wastewater pH should be between the value of 6.5 to 7.5 pH value. Then final sludge treatment of accumulated sludge, because as the water is moving from the primary to the secondary and to the tertiary, there are sludge that are being settled down at the base of this stage. Then the final thing is that you treat all the accumulated sludge. It's either you scrap off the sludge and take it away, or you dispose the generated sludge, or you treat the sludge, or if the sludge is being generated in a huge amount, this can be converted to generate electricity. It's just only that when you have it in small quantity, it is not advisable because of the huge amount of money it's involved in getting it done. So generation of electricity with sludge, thermal destruction, so burning of and drying of sludge to generate heat. Heat is turned into electricity. These are all areas where you can use the sludge generated from your sewage treatment. Then operation and maintenance of sewage treatment plant. Pumping of the aeration, you use your pumping machine. Pump are required for treatment purposes. Then your sludge remover, you use your what? Your pump as well. Then remember, you have your sludge is being settled. Your sludge is being settled for test. You carry out tests on your sludge to ensure to discover if it is of good quality that you can use in generation of electricity or not. Then this is how the analysis of your waste water looks like after you have treated it. You remember I said your pH should be between what? 6.5 to what? 7.5. That is before treatment. And after treatment, it must also be 6.5 to what? 7.5. Before you can be allowed to discharge it into what? To public drain. And your POD should be 10 milligram per liter. Your turbidity should be less than NTU. And E. coli should not be what? Not specified. So there could be some presence of E. coli. So what are the environmental implications of sewage treatment plant? One, there's no how you're going to have a sewage treatment plant you won't have odor. You can't rule out odor. One, population exposed to sewage sludge complain of odor. Odor indicate the presence of what? Septic condition, aerobic condition, which is absence of what? Oxygen. Compound formed from protein degradation emit very stingy smell. Pretreatment and treatment stages form compound that contain foul air. Compound that contribute to odor are nitrogen, sulfur, ketones, acid, and what? Adides. Odor affect the quality of life of those that are consistent exposed to the sewage sludge. So that's why when you have a sewage system or you have a sewage treatment plant, you have to, odor is part of what you'll be dealing with extensively. Then how can you reduce your odor in your sewage treatment plant? You can use chlorine, you can use carbon reactor, you can use calcium nitrite, you can use hydrogen peroxide or iron salt. Then effluent quality. Sewage must be adequately treated to avoid effluent emitting odor, that is the treated wastewater. Reduce the level of BOD and pathogen release into the water. Reduce bacteria and organic pollutants. Waterway that receive effluent from secondary treatment plants are less important than waterway that receive effluent from primary treatment plant, because the primary still contain a huge percentage of what? Waste water. Consider the assimilative capacity of the waterway before giving approval for effluent discharge. So what are the disadvantages of your wastewater? It can cause corrosion. The solid and liquid from sewage treatment process are very corrosive. Causes damage to pump, tanks, and pipe, meter or panel. These are all what can occur if you have a poor sewage treatment. How can you control your pipe corrosion? Pipe should be made of what? Inert material, just like your pressure pipe. RCC material with sacrificial lining for large pipes. These are all how you can control your corrosion in your pipe. Then don't forget, when you have a treatment, a sewage treatment plant, these are all flies that you can't rule out, which is midgets. Midgets either called fly larvae, blood or red worm thrive in water sewage treatment plants. These are more or less like flies that comes along with your sewage treatment plant. Then in your sewage treatment plant, if you don't take care of all these flies, you can have all these big house flies. If you don't treat them very well, you could be spreading diseases within the environment. Discharging of poor or untreated sewage causes a lot of diseases. Health issue. The sewage discharge pollute the water, spread diseases, and destroy what? Aquatic living. And that's why Lagos State always specify, it's part of Lagos State environmental code, that buildings that are more than 2-story building should have a sewage treatment plant, because they believe you are generating a lot of what? Wastewater. Then this environmental implication of sewage plant: pollution of water with toxins, excess nutrients, heavy metals, pathogens. Pathogens end up with in swimming pool and drinking water and causes dysentery, hepatitis, diarrhea, respiratory infections, heart diseases. An estimate by the Environmental Protection Agency showed that between 1.8 and 3.5 million people get sick from contact with sewage from the overflow of sanitary sewage annually. Such illness and diseases can be very deadly for children and also affect about 30% of the elderly and other patients with weak immune system. And this brings us to the end of sewage treatment plant. So you have an assessment at the end of the assessment is a combination of plumbing, treatment water plant, and sewage treatment plant. So you go through the same process, get the assessment reviewed, attend to the assessment, submit through the same portal, and so we'll be going to questions and answer section now. So you raise your hand you signify by raising up your hand. So Mr. Chovu, let me just quickly attend to you. I have Mr. Abdul Samad online. So Mr. Chovu, go ahead, please.
Yes,
Mr. Chovu, please go ahead.
you just talked about Lagos State requirement.
Yes. Mr. Chovu, please go ahead. Oh, I guess there is a network there. Okay, Mr. Abdul Samad. So we'll come back to Mr. Chovu later.
Good evening.
Good evening, sir.
Ogami, you are doing well, for real.
Thank you very much.
Yeah. I actually told you like I'm an educator and I study biology, and
Okay.
this course sewage treatment and all make me remember some part of courses I did during university days. So I want to ask this particular question. You've been clamoring on sewage. What about refuse? Because I actually know that refuse and sewage, they're actually different. So how do we treat refuse? And yes, so how do we treat refuse and monetize it as a facility manager to contribute to the growth, you understand, to the income of a particular company you're working for?
It all depend on the kind of waste you are generating. The waste you are generating will determine if you can make money from that waste or you can't make money from it. As a facility manager, you have a generator in your facility. One of the waste you generate from your generator is your black engine oil. That means your used engine oil. This you can make money from it. Or your keg that is being used to supply the fresh engine oil. Or the drums, if you are buying your engine oil in drum, you can sell off the drum, get money back into the facility. But when you are generating a paper waste, you can sell your paper waste if these are reused paper waste, if not, they are not shredded one. If they are shredded one, that means you need to find a means of disposing them off. But if you have this shredded one in large quantity, you can sell them off to all these sanitary ware company where they produce all your toilet rolls. You can sell all these things to them. They use it to producing their toilet rolls as well. These are all where you can generate you can use your waste to generate money. Or possibly if you have a factory that is making fertilizer, you can sell your food waste to them. But your chemical, your medical waste, these are not waste that you can sell to regenerate money. No. If you can you even have to spend money to dispose of all this waste because you need experts to dispose of all this waste. You can't just throw surgical blade elsewhere. No, you need experts. And you need an approval to ensure that there is a kind of what we call a feedback that waste has been disposed of. There is something that is under United Nations. The United Nations has something that we call Sustainability Development Goal. And under that Sustainability Development Goal, part of the goal is that there is what we call transboundary movement of hazardous waste. If you're moving an hazardous waste from Nigeria to Ghana now, there must be a consent from Nigerian government that if Nigeria is moving to Ghana, there must be a consent from Ghanaian government that, okay, we need to move this waste. And Ghanaian government has to give an approval that, okay, you can move this waste because it's an hazardous waste. You can move this waste through our border. And after they give that approval, you move the waste. And when you dispose of the waste, there must be a kind of a feedback showing that waste is correctly and professionally being disposed of. So you can generate money from your waste. You can also spend money to dispose of your waste. So, Mr. Absamad, I hope that answers your question, sir.
100%. Thank you very much.
You're most welcome, sir. Yeah, Mr. Adiola Anthony. Okay, Madam Adiola, Mrs. Adiola Anthony.
Good evening, sir. Thank you
Please
for the
pardon
class.
me for using the word Mr.
It's okay, sir. Okay, so I have a couple of questions. You talked about
okay.
Yeah. You talked about
Husband and wife questions.
You talked about part of our water treatment, and you talked about daily backwash. So I'm just wondering,
Yes.
like when you have an estate, are you saying that
Yes.
for their water treatment, the backwash should be done
Yes.
as a daily activity? That sounds like
Yes,
a
because
bit,
you have a
that sounds
dedicated
like a lot.
technician. Okay, that is one.
Okay,
Should
that's
I answer
question.
that one, or you want to?
Okay, let me ask all my
Or you want
questions.
to give your?
Okay.
Okay, that's number one.
Then the second question, you talked about magic waste is being used instead of the bottle trap waste. So why is that? Why is that done? Why is it used instead of the bottle trap? That's
Okay, magic
question number
waste.
2. Yeah, you said now the
Okay.
more modern usage is now we use the magic waste instead of the bottle trap. So I want to know why. Why is that done?
Okay,
Then,
go ahead.
and my third question.
That's just only the two questions, right?
No. My third
Okay.
question. My
Okay,
third
ma'am.
question is, can you explain more about the, is it stack sewage system, or I don't know, I didn't really understand that stack thing that you were talking about. I didn't really get it. That's my.
Which aspect are you talking about there?
That stack is under, let me see, water.
Tap, that is under plumbing.
Yes, under plumbing, yeah, under plumbing.
Tap.
Stack, S-T-A-C-K.
Stack, okay.
Yes. And then my last question is, can you explain
Number 4.
a little bit more? Yeah. And okay, I have one more question. Okay, can you explain a little bit more about the casted sewage system?
Casted,
and then
okay.
Yes, and then my final question is, if you have a case, I know you tried to explain it in the last bit of the lecture, but I didn't really get. If you have a situation where you're having smell in your toilets, I guess that's it.
Okay.
How do you treat that? As in, it's a finished building, is existing and is being occupied, and now you have that smell. So what steps can you take to treat that? Yeah. So
are you having the smell in the toilet or in the urinal?
It's a bathroom, shower, and WC all encompassed in one space. But I think it's coming from, so I think it's coming from the drain. That's the shower drain. Yeah, I think that's where the smell is coming from. So how do you treat?
So we have 5 questions altogether. So
Yes,
let me
sir.
do a recap of your question. Let me do a recap of your question, ma'am. The
Okay,
first
sir.
question is that if you have an estate, is it compulsory that you have to do a daily backwashing?
Backwashing.
Then question number 2, you say you want to know the difference between magic waste and bottle trap.
And then why we use it, yes.
Question number 3, you said you need more explanation on stack.
Yes.
Question number 4, you said you need more explanation on casted sewage system.
Yes, sir.
Why number 5, you said
number 5.
Smell in the toilet. That's number 5.
Yes, sir. Yeah.
Am I right?
Yes, sir. You're right.
Okay. I take them one by one. The daily backwashing, you said if you have an estate, it is not all about having an estate or all about having a single building. If you have a filtration filtered water treatment plant in your facility, either estate or wherever, the nature of the water required that at times it might require you to do twice on a day backwashing. And that's the reason why in an estate you have a staff that is called a plumber. It is the responsibility of the plumber to ensure that he does what we call a daily backwashing. And why do you need this daily backwashing? Because your filtration media has medias inside, and that media are sand and all this whatever combined together. As soon as water goes inside that media, the contaminants keep settling on those media. if you are not doing backwashing, it will come to a point that the media will be so choked to the extent that the volume of water, the rate of water getting to your treated water tank will start depreciating.
Okay.
And along the line, you will see at the top of this seal cylinder, there is what we call a packing. You will see water leaking from that packing or from the one that is at the front side of it. And what is actually causing this is backflow of pressure within the entire system. So that's why you need to keep doing backwashing on a daily basis. Then the second thing is that if you are not doing backwashing, you are, most especially if your water has what we call high concentration of iron,
okay,
you will start having your sanitary wares getting brownish. That's why backwashing is very, very key. It is must be done. It doesn't have a time value. You can do it in the morning, you can do it in the afternoon, you can do it at night. It must be carried out on your water. Then, if your water has a leaking nature, you need to wash off the accumulation of even the injection of chlorine and your halon. Where do you think they settle? They settle inside your filtration media.
Yeah.
And you have to wash them off. That's why it is very, very key. It's not about when you are in an estate or when you are in a mall or you are even using at your own house. It must be done. Now, I hope that answers question number one.
Okay, yeah. So I want to ask, so that means that literally at the time when you are doing a backwash, you are turning off your water system. Is that not what it means to do a backwash?
When you are doing your backwashing, you close the valve that take water into your treatment water tank so that the dirt you are washing away doesn't find its way into your treated water tank. Okay. So when you complete your backwashing, you open the valve and turn everything to the filtration system.
Okay, but it doesn't affect your water supply, or you have to also turn that off. That's your supply to your users.
No. It doesn't affect your water supply because when you are supplying your water, you are using different pumps. You have two different things. In your water treatment plant, you have filtration pump and you have transfer pump.
Okay.
The filtration pump is meant for your backwashing, while your transfer pump is meant to transfer water to every location within the facility. So it doesn't affect each other. You can be backwashing. Your backwashing doesn't take time. The maximum time you can spend on your backwashing is 30 minutes. So you can see it doesn't even affect the whole because you have a storage system where you take water to distribute to the whole entire.
Yes. Okay. Thank you for that.
So it doesn't affect your distribution system.
Okay.
Then you're asking about the difference between magic waste and bottle trap.
Yeah.
Bottle trap. The advantage of bottle trap is that bottle trap then has something like a bottle under it. There will be a time that your washing zinc doesn't flow. What do? You go to the bottle trap, open that bottle, clean it off, and replace it back. But because bottle traps they are fixed, they are not flexible.
Okay.
So there are some certain areas where you can use bottle trap. When you have areas that are big, you have a lot of bends.
Okay.
Because bottle trap is just like a straight pipe. You can't bend it, it's not flexible.
Yeah.
But your magic waste is flexible. You can bend it around.
But it doesn't have that advantage of collecting all.
You have the advantage of flexibility with magic waste compared to bottle trap.
But doesn't have that collection.
The advantage of bottle trap is that you can clean off the waste when it's blocked. But with magic waste, you remove it from the point at which it enters into the waste pipe to clean any accumulated dirt that is inside, and you return it back. That's just the difference between the two. Now you're talking about stack.
Yeah.
If you have a 10-story building, for instance, all the waste that is generated within that 10-story building comes into a sewage system, centralized sewage system. Because you want to do away with what we call odor, you want equal and exchange of air within the entire system. That's the reason why you always have a stack. There is always a main stack. For that 10-story building, you are going to have a straight pipe emanating from your sewage system down to the last floor. And on the last floor, you are going to give it a vent so that there will be exchange of air from external air going into the sewage system and another one come from the sewage system going out. to avoid odor, just like what you have in your toilet. So you need to go and check your stacking system when you get back home. Then, at the same time, you need to check your urinal. If your urinal drainage system is done on a horizontal line, if it is not inclined, there will be settling of water when you urinate inside that place. And you know your urine has what you call ammonia.
Yeah. It
ferments faster compared to any other chemical. So you could be having that odor. Then the second thing is that if your WC, there is something we call pan connector. That is what connects the outer of your WC to the waste. If the pan connector is not properly fixed, there could be backflow of odor. That is one. Then two, if your WC is not retaining water, because the water retainment to your WC is also serving as something like a non-return valve that restricts your air into your sewage system. It doesn't allow the odor to come back. So that is another word that water in your WC is doing. So those are other things you need to check.
Okay.
Then question number 4, right?
Casted.
You said casted sewage system and non-casted.
Yeah.
The location where you want to sink your sewage system will determine if you are going to use the casted one. Because on the island, even when you dig just ordinary one ruler on the other, you can start seeing water.
Mm-hmm.
Am I right? That is the reason why you can, on the island, you can never have what we call soak away system.
Okay.
And that's the reason why your sewage system on the island is always you cast the sewage before you return it. Because even during the period of digging the location, the point where you are going to sink the cassettes, whatever, you start seeing water. At times you have to go and rent all the sewage pump to pump the water out before you can put the sewage inside. But on the mainland, talking of somewhere like around Ikeja, going to Songo area, Yanopaja area, going to Magudu area, Ibadan Expressway, I'm not talking about Kara, neither am I talking about all these Magoro, because those areas are riverine area. But when you are talking about all this Ojota area, I'm not talking about somewhere like around Ogudu.
Oh, okay.
Those areas are riverine area.
With the swampy.
Swampy area. So, but when you are talking about somewhere around all this Yanapaja, all this Ikeja area, you can have a soak away system there because the ground around that place are not saturated. Water can still percolate. That's the reason why you see the wall of your sewage system are being made of perforated blocks.
Okay, so it does.
So that the water can percolate. And that's the reason why you don't evacuate. Your frequency of evacuation is very, very reduced compared to on the island. Even if at all you are going to evacuate, it might be once in 3 months. And that's the reason why you see these guys that do the evacuation, they always come with a kind of a shovel, a vertical shovel, that they first of all injects water into it, because what you have is caked material.
Mm-hmm.
So they first of all mix everything to become liquid form before they can evacuate. That's the difference between your casted sewage system and non-casted one. Then you are talking about smell in the total. I think I've answered that one when I was talking about stack.
Yes. Yes.
So I think I provided
answer.
Your
smell, if the smell is coming from the drainage, the shower floor drain, what is
you can divert the shower, you can rechannel that drainage.
Okay.
You can rechannel it.
Okay. All right.
Thank you very much.
Yes,
You're much welcome. So, Mr. Kingsley.
Good evening, sir.
Good evening, Mr. Kingsley.
Questions are, the first one is on plumbing. You talked about the overhead tank and the underground tank. That is
overhead tank and surface tank.
And the surface tank, sorry. At the overhead tank, there's always a T junction where you have a pipe going up from the outlet tank up. I want to ask, what's the purpose of that tank? Is it for air restriction?
That pipe is meant for two purposes. Okay. The height of that pipe is always lower than the height of your tank.
Yes.
So the first advantage is that once you see water coming from that pipe, it tells you your tank is about getting filled up. You need to put off your pumping machine.
Okay.
That is one. Then two, it serves as air trap. It serves as it prevents air trap from your system. If you have air trap in your system,
Yes.
you can have water inside that overhead tank and you won't have water inside the building. It's just like when your pumping machine is run dry of water, the pumping machine will be working. There will be water inside the tank, but it will not pump water. So what do you do at that period in time? You stop the pumping machine, open the top, put water inside it, close it back, and it will start pumping water. So that pipe you are saying is doing two purposes. One is to tell you what tank is about to get filled up. Two, to prevent airlock in your system.
Okay. The second one is at what pressure range is advisable to set your pressure pump for those using the pressure system?
It all depends on the quality of your water. It all depends on the quality of your water. The quality of your water will tell you the quantity of dosing you need and the rate at which you need to dose.
No, I mean the supply from your overhead tank. If you are using the pressure system to feed the building for domestic use, at what pressure range do you need to?
You can't regulate the pressure. It's all depend. The pressure is depending on the size of the pumping machine you're using. If you are using 1 horsepower pumping machine, the pressure will be 1 horsepower pumping machine. If you are using 2 horsepower pumping machine, you are using a 2 horsepower pumping machine pressure.
Okay. Then the third one, in your sewage treatment plant, where is best to add your chlorination before the discharge? At what chamber level? At what stage is best to add your chlorine when carrying out?
If you check the slide, when we're discussing it, we talk about the tertiary, we talk about the primary, we talk about the secondary, and the tertiary. Yes. That's the point at which you inject your chlorination.
At the tertiary stage?
Yes. Check the slide.
Oh, okay. Then backwashing.
Yes, sir.
For backwashing, is it advised to use to add your chemicals, the chlorine, soda ash, or whatever you are using?
That is not
the backwashing stage.
Mr. Pisley, that is not backwashing. Okay. When you want to inject, you inject directly to the water that is coming from the borehole into your raw water tank. Then you not use another pumping machine to take it from the raw water tank through your filtration system to your raw water, to your treated water tank. When you want to do backwashing, you use your filtration pump to take water from the raw water tank to do what we call backwashing. You don't inject when you are doing backwashing.
Okay.
Backwashing means you are washing all the dirt accumulated in your filtration tank out.
Okay, thank you very much.
You're much welcome, sir. Yeah, Mr. Bamidele. Oh, sorry,
Good evening,
Mr.
everyone. Good evening, everyone.
Okay,
Thank
Mr.
you so
Bamidele,
much.
go ahead. Then I'll attend to you later, Mr. Victor.
Thank you so much for the lectures. I really gain a lot from it. And plumbing is one of the aspects that if a facility manager must not play with, because he's rendering service to the customers, and everyone need water. My question goes that what does in a sewage treatment plant, and you didn't make emphasis on the dose pump. What is the importance of the dose pump to the sewage treatment plants? That is the first question.
No, Mr. Bamidele, which of the pump are you referring to? Because we have
the sewage treatment plants. I think it always has a dosing pump beside it.
Yes. Yes.
You didn't so much. You didn't make any mention of. I didn't hear when you were talking. You didn't talk about that when you were giving the lecture.
We did. The dosing pump you use for your normal water is what you use for your sewage at the same time, because what you are trying to inject is chemical.
Yes.
Yes. So okay. You can use the same dosing pumps that you are using for your raw water, for your sewage water as well. You are only trying to inject chemical into. So if you are treating them in large scale, your dosing pump has varieties, which is being measured by bar, the number of bar that they can push. So the size of your sewage plant will determine the size of the dosing pump you are going to use.
Okay. Thank you very much. The next question I have for you is that, we have water heater that is attached to each of the pumping, maybe that supply water into the residents, in the bathroom, in the kitchen. And in the present, this thing we manage in my company, we have what we call solar water heater. So it's a central water heater that supply hot water to various apartments and residents, right from the 5th floor all down to the 1st floor. But one of the challenge we have with this solar water heater is that, you know, the level at which the hot water gets to each of the floor, the times differs. And, you know, it's not like the water heater, normal water heater that you just open and hot water will start coming out. The level at which the solar water heater drop at the penthouse is more faster than at the 2nd floor or the 1st floor. And most of our customers, our tenants, they are complaining that they don't get this hot water on time. What solution can we do to make sure that the hot water gets to their apartments on time?
You are using hot water, you are using centralized water heater, right?
Solar, yes, sir.
No, I said centralized. Let's forget about either solar or whatever. That is a power. Solar is just a power source.
Yes, sir.
Are you getting me?
Yeah, it's centralized hot water, yes.
So that is what I want to know. It's centralized. Where is that being located? At the penthouse, at the rooftop, or on the ground floor?
On the rooftop.
On the rooftop?
Yes, sir.
If it is located on the rooftop, then you have the piping network going to each of the apartments, right?
Yes.
Okay. You know, initially when I was talking about when you are supplying with gravity, there is always what we call pressure differential. It happens in our different homes as well. If you are staying in a 2-story building, the ground floor gets water faster compared to the 1st floor because of pressure differential.
Yes, sir.
So the challenge you are having in that place is called pressure differential.
Okay, sir.
And the only thing you can do is if you can relocate down and use pressure pump to distribute, you have equal pressure in all the entire building. But if it is going to be cost intensive, you have to just live by it. Because if you have to start spending money and every other thing, running into millions of naira to get that done, it might be a bit. So even if it is inverter or normal power, the inverter, the solar is just about the source of power that is powering that central water boiler. The boiler is distributing water. So the piping network is you are supplying with gravity. When you are supplying with gravity, there will definitely be what we call. There is a. Can that person help us move the speaker?
Sorry, my apologies. The update I gave you.
So there will definitely be pressure differential once you are supplying with gravity. That is what the challenge you are facing in that place. So, Mr. Victor, Mr. Bandele, are you trying to ask another question?
Yes, my last question is the storage tank. You know, we have the underground storage tank and the what's it called, the overhead, maybe on the roof level storage tank also. My question is, we're operating these two on the various projects I've been to, but the one we have challenged most was the underground storage tank that supply water from the ground floor down to the 5th floor. And one of the challenge we have there is that the machine runs 24 hours. And I want to know, yes, 24 hours, because the moment you open your tap, automatically the water will start pumping. The pumping machine will. The pressure of the water will go up. But there was a time we have challenges with there was a breakdown of the machine and there was no water in the residence. And it was a big issue. I want to ask, which of them is the best? Is it the storage, the one on the roof level or on the underground? Which of this water storage tanks is the best to use in a residence?
The two of them are perfectly okay. if you have the underground one, that means you need to have consistent power supply. Because if there is no consistent power supply, because you need pumping machine to lift the water from the underground into the building. And if there is no power, there's no water. But with this overhead, even when there is no power, you can still have water. So you only need, that's the reason why in our different house, we only use our generator at times to pump water. Once we pump the water, if we don't need that generator for any use, we only use to pump water. Once the tank is filled up, we stop the generator and we keep on having water. But it's not possible when you are having underground tank. You need to have consistent supply of what? Power. That is when, as soon as you stop, if you are using your generator, if you have underground tank, immediately you stop that generator, the water stops in that building. So the only advice I can give you is that you can have a redundant machine. What I mean by redundant is a standby. So that in case if one fails, the other one will work. So you don't depend on only one single machine. In order for, if you want each free operation, you need to have at least 2 pumping machines, 1 dual, 1 standby.
Okay, sir. Thank you very much, sir.
You're most welcome. So, Mr. Faith. Oh, sorry, Mr. Victor. Mr. Victor, Mr. Faith, please.
I would have wondered what I I would have wondered what I did.
Please go ahead. Sorry about that, sir.
All right. Good evening. Good evening, sir.
Good evening,
it was a nice time. Your lecture was very, very interesting. I enjoyed it. So I'm trying to say now, you made mention of something when you were talking about situating the sewage treatment plant within a perimeter, and you said the setback from the fence must be at least 6 meters or something.
Yeah, from your fence wall.
From your fence wall. Okay.
Yes.
In a case where, you know, I'm trying to see how you can marry this with the development control or building control authorities, because now the normal setback of your building from perimeter fence, like from the side, is 3 meters, or from the back, or from the front is 6 meters down here in Abuja. So now most times developers or people who want to build, they tend to situate their septic tanks or soakaways or STPs close to, or the lowest part of the land, and also close to how do I put it now? Close to the back of the building. You understand? And most times the space is usually not up to 6 meters from the fence. So now, how do we marry this? I'm saying this because I also have projects that we're doing, and we have this setback issue, and most times it's not up to 3 meters, it's not up to 6 meters. At most 4 meters, 3 meters setback for we to situate soakaways and septic tanks. How do we marry this the global best practice coupled with the development control what do we put it now? Development control rule or regulations in trying to situate all this?
Okay, Mr. Victor, that is a very good question. At times space constraint during construction might be one of the challenges that we're going to face in achieving this. Then in that situation, if you're going to get your sewage closer, if it is a reinforced sewage system, it is possible because it's reinforced. So you have less or little amount of water getting into the fence wall. So then if you have a space constraint, the other thing you can do is to ensure that the fence wall, the foundation of the fence wall is designed in such a way that it can accommodate that. Otherwise, if you do it, you have a challenge at the end of the day, because it will come to a point, because if you have a soak-away system, if you do a sewage system that is a soak-away system that is very close to your fence, there is tendency of the whole entire area getting saturated, and the wall of that sewage could collapse, which will have an adverse effect on your fence wall if you don't have a strong foundation for your friends. You could be having what we call structural differential. So in situation whereby you have a space challenge, you could improve on the foundation of the fence wall so that it will be able to accommodate whichever stress that it will be subject to in the nearest future. These are other options that you can take. Yeah, Mr. Victor. Hello, Mr. Victor.
Yes, you have answered. But I'm trying to ask one more. Sorry, I discovered.
Okay, go ahead, sir.
I discovered that you dwelt more on, like this training actually dwelt more on sewage treatment plants. And the most common waste disposal in terms of sewage disposal method is soakaways and septic tanks. You understand? So how do we get more training on that soakaway and septic tank aspects? Because majorly, I can tell you, when you count like 10 buildings, you have like 70% or 80% using septic tanks or soakaways.
Yes, of course. The only thing I can advise you is that you go for more further training on this. There are several other further training that you can do on all this area that will definitely assist or help you. Hello, sir.
Yeah,
Mr.
understood,
Victor.
sir. Understood, sir. Yes,
yeah.
Yes, thank you.
Yeah. So, Mr. Faith.
Thank you very much. I join my colleagues in thanking you very much for comprehensive coverage of the plumbing, sewage treatment plants, and water treatment plants. I hope you can hear me.
What don't you understand now?
Hello? Hello?
Go ahead, sir.
Okay, thank you. So oftentimes my thoughts is always, okay, how do we, so as a facility manager, because we are being trained, or we are getting trained.
Your line is breaking. Your line is breaking.
Management. As a facility manager, although
yes,
I changed position, so I just said as a facility manager, although some of us, if not most of us here, will not be taking span.
I can barely hear. Can you type your question on the chat?
And screwdriver and co and be hand.
Mr. Samuel, please go ahead. Mr. Faith, we can barely hear you. Send your question via typing. Type through the chat portal, so at least I will attend to your question. Mr. Samuel, please go ahead.
Okay. Good evening, sir.
Good evening, Samuel.
What I wanted to talk about is not really a question, but I just want to confirm about Mr. Bamidele's previous question earlier, which is about the hot water. Because I have similar issue at my workplace, but in this case, our tank is on ground floor. The water heater tank is on ground floor, and that's the supply for the whole building. It's a central supply also. But in the I just want to confirm from him too, in case if he's hearing, is it that water take longer to get to some rooms in the apartment, like the hot water? Because before the water will travel from upstairs downstairs, might take a longer time. Because initially the water in the pipe must have been cold. So what we did in my own workplace when we had similar issue was we created a water purging system, which is there's a place exactly that as maintainers we can just go there and purge the water. So we purge it frequently. Once we purge it, the cold water that is in the system will be purged out. So we will have the water in the pipe warm. So anybody that tends to open hot water in their room will definitely get it within a snap. So that's just what I wanted to confirm. If it was that, okay, some apartment were getting hot water late or another thing. So I just said I shed more lights because I experienced something like that too at my workplace here.
That is very fantastic. That is another option again. But I think he's saying that their tank is located at the overhead roof.
Okay.
Yes, sir. It's located at the or at the roof level.
Yeah.
Thank you. Thank you, Mr. Sam.
Okay.
You're welcome.
So, Mr. Faith, you can send your question via chat or send it through Barakat. Barakat will send to me, then I'll provide the answer, then you have it back. I think your reception is very, very poor. So, we will be rounding it up. So, let me say thank you, everybody, for making it a day to attend this class.
Thank you.
So, see more of you during the facility tour very soon. Thank you, thank you, thank you, and have a lovely week ahead.
Thank you, sir. Have a good evening. Thank you.
Thank you very much.
Sir.
Thank you, sir.
Yeah, thank you.
Enjoy the rest of the evening.
Thank you. God bless
you too. Thank you, everybody.
Thank you, sir.